So hello and welcome to the DV Digest. My name is Brody and this is your monthly digest of insight from design verification leaders. Now, today on the podcast, we're talking about everything agentic AI with possibly the most qualified person to talk about the subject with, Hamid Shojaei. Hamid has been a senior manager on Google's TPU team. He's led a verification team at Lightmatter, and most recently and relevantly for this conversation, he co-founded ChipStack, which is basically an agentic AI platform that uses LLMs to automate a lot of the design and verification process. It was founded in 2022 and it was acquired by Cadence at the end of last year, and Cadence recently released it as part of their offering early this year in February. Much of my network has already told me just how impactful this new release has been for them, and so I thought it was only right to go and talk to the muscle behind the operation, Hamid. We talk about agentic AI and its potential to replace verification engineers. We also talk about the limitations of the technology and where engineers are still needed. And finally, we talk a bit more about how to strike a balance between automating and reliability. I thought it was a super useful conversation, super insightful for me, and I really hope you enjoy. Starting off, Hamid, where do you see verification changing in the next 5 years? How do you see it evolving?
Yeah, so that's a very good question. I feel a big portion of the verification in future will be fully automated by AI. So if you think how verification engineers work, like day-to-day tasks that they do, so they spend a lot of time on design understanding. So there is a lot of back and forth between design team and verification team, a lot of questions, so they understand what is this design, what are different functionalities, and how they need to verify that. So we know that like AI is very good in like reading a spec and your artifacts and summarize them and help you understand the design. They also spend a lot of time like writing test plan, and after that, they code the test plan in code, whether it's like SVA assertions for formal verification or UVM test benches for simulation. They spend a lot of time like writing these codes, and again, we know that LLM is perfect in coding, and they can write very high quality code. And then the big portion of their time is debug and coverage closure. So all of these, if you think about it, are reasoning problems, and LLM can do a perfect job over there. So in my view, future, a lot of these steps will be fully automated by AI. I feel verification engineers are still needed. They will be on the driving seat and helping AI to generate better results. But the heavy lifting part will be done by AI.
And so obviously you've already started with ChipStack. Can you talk to us a bit about the functionality of ChipStack, what it does, when it's in the hands of a verification engineer, what are they seeing?
Yeah. So we have different super agents, we call them. So we have a design understanding or mental model agent that can help you understand what is this design and extract different functionalities and features of the design. We also have a test planning agent, which can generate a test plan for formal verification or simulation, depending what you want to do. The format will be different. We have coding agent, and also we have like end-to-end agents. Like for example, our formal verification agents start from spec and RTL and can go all the way to even running the tool. Like in this case, like we run Jasper for formal verification, and even debugging the results and iterating until like all of your checks are passing, and ultimately dumping all the results. So we have end-to-end agent for formal verification. We have UVM agent that DB engineers can use to generate UVM test benches and run them. And we are coming with debug and coverage closure agents.
In terms of the roadmap then, what's next for you guys?
Yeah.
That sounds like a lot. What else have you guys got to do?
So our roadmap is to fully automate design verification. I can like imagine in future there will be a design agent and a verification agent. And chip design engineers can just give the architecture spec to these two agents. These two agents can work hand in hand very closely together and design the microarchitecture spec, verify it, and even do physical design and dump the GDS at the end. So our roadmap is to fully automate verification, then start doing design, and we already started on that, and also cover other functions of chip design.
How confident are you in the output of these agents?
It's a good question. So if you just want to run the agents and just don't review anything, definitely the results are not as expected for larger designs. That's why I said human in the loop is very important for our strategy. And we made it very easy for engineers to review the results, give feedback, and work with the tool until the last step. So if you don't review anything and you just run end to end, it's possible that the results somehow sometimes are not perfect. But we have seen about 70 to 80% like accuracy compared to like just using LLM. And that also depends on the complexity of the design.
So you say that you want to fully automate verification. Is this a matter of improving the system around which the LLM is built? So can you get there on your own with capabilities where they are now in the kind of foundational models? Or is this a matter of foundational models improving in order to get there to the accuracy that we need?
It's a very good point. So we did some experiments on fine tuning, and I completely agree that the models are not like fully ready for chip design at this point. As you can imagine, we don't have very high quality data on chip design available online. So compared to C++, Python, and other languages. So definitely models need to be improved. And I know that all the LLM providers are actually working hard to improve their model for chip design. So that's one aspect that needs to be improved. And on top of that, other techniques, and it doesn't need to be like full training, could be SFT, could be RFT, and we have seen very good results just doing reinforcement learning with few samples, and suddenly we saw a big jump. So yeah, those fine tuning should happen. Plus, like flow engineering is another like key advantage. Another advantage I see like at Cadence we have right now is that we have full access to EDA tools. And I have seen that like for LLM to generate better results, you need to give a lot of feedback. So this feedback can come from EDA tools or from human. So if we know that, like we change our EDA tools so that we can provide more feedback and faster feedback to LLM, then definitely we can get much better results.
I know this is going to be a bit of an unfair question, but what sort of timeframes are you looking at between now and being able to fully automate with human level accuracy, I guess, the
Mhm. Mhm.
verification process?
Honestly, I'm not sure if that will ever happen. Like I feel humans should be in the loop all the time. Even in software, like we see these models are perfect in software coding, but it's still like all the available solutions like Cursor, Devin, Cloud Code, Codex, Gemini CLI, all of them require human to review the results and do the sign off. I think the same thing will happen in chip design. A lot of steps and heavy lifting part will be automated, but still human has to be in the loop and review the results and do the final sign off. So that those stuff, I don't think they can be replaced by AI.
Do you have any thoughts on, as capabilities improve, any sort of heuristics that we can think about when it comes to how much oversight is needed in any given system? Like, how do we actually think about that as capabilities are improving, the trade-off between making sure it's right and saving time?
Mhm. Um, so again, like my experience is that it's different from design to design. Like for example, formal verification that I use as example. So if you run, I don't know, arbiters, FIFOs, this basic controller modules, I think would be even 100% automated. And this library cells, library modules, people spend a lot of time verifying them. So those could be fully automated. For complex designs, when you come to subsystem level and SOC, I think it's still like 70% of the work should be done by human. But the good thing is that they don't need to do coding anymore. They can just for example, interact with ChipStack using natural language. Say, for example, implement a scoreboard this way and that way, and the agent can take it and do it for them. So that's why, like, fully automation over there, I think it's like, I don't know, far from reality at this point. Maybe in future things will change, but with the context size and so on, right now at SOC at least cannot be fully automated.
Capability is changing all the time, and on one hand you're saying, you know, you need to trust these tools a bit more, and on the other hand, you know, you do need somebody to be checking that these things are right. I'm just trying to figure out the sort of best way to think about that for any given problem and any given flow. I mean, is there any tips that you could give to someone that's sort of thinking about that problem?
So how to do like this balance between trusting the tool and reviewing the results, right?
Exactly, like how to
So
find that balance.
yeah, yeah. So they are not conflicting. So again, like think about if you go and hire some junior verification engineer. So definitely you trust them, but at the same time, you review the results. They ask them to send you the results and review them. And the final sign off should be done by someone who has like more experience. Because as you know, in chip design, tape out is very critical. You don't want to miss any bugs and any issues. So that's why like you have trust, but you also do review so that experience is there. I think the same thing applies here. So definitely, we know LLM can do better job, and that has happened in software. Every software engineer is using a lot of AI assistant, and the productivity has increased significantly. But that doesn't mean that they don't review the results. Even if you use AI to write a simple email, you still read that email to make sure that this is correct before you send it. Um, but then the key point here is that you need to make it easy for human to stay in the loop, review the results, and give feedback. And we have done that at ChipStack. At ChipStack, you can see every artifact step by step. Like right after mental model, we show the mental model in a very readable format to the user. Ask them to review that and update any field, like manually or even with high-level instruction before we go to next step. So basically, instead of spending, like, for example, weeks to write your test plan, so you can use this tool to generate the test plan in a few hours and then spend maybe another day on top of that to review and make sure this is correct before you go to next step. So it will still significantly save time. But at this point, you cannot just give it to the agent and say, go to the end and do everything for me. So that's my point. So definitely these are not conflicting with each other.
I'm hammering home this point a little bit because I know it is kind of super
Yeah.
important and what I know managers are thinking about at the moment. W- what do you think the line of accuracy is whereby we can start trusting it entirely? Where is that line? Is that what you'd expect from a human? Is that perfect? Where's the line exactly?
Yeah, so that's a good question. So first of all, the same verification metrics that we used to have in the past still applies here. Like for example, we measure the coverage, how much coverage this test bench that was generated by ChipStack is giving you. And for coverage, we are considering different metrics like line, I don't know, toggle coverage, functional coverage. So all of them are considered. And that's one metric to show to the user that if all the metrics are 100%, means that I verified everything for you. So that's one important metric you should do. The second thing is, and I think it's the most critical one, is what we call mutation testing. So what we do is that, so you can go and inject different critical bugs in your design and show that like the test bench that we were generating can catch all those bugs. So that's like it gives you a lot of trust that any bug that I was able to introduce to my code, this test bench was able to catch it. So that's another like very important techniques that you need to do to so that you can trust what is generated. And also, I think for LLM, another area that we are considering right now is to come up with new innovations based on AI so that we can give this trust. For example, instead of using tools that can do a bug injection into your design, maybe LLM can come with some bug introduction. And you have a, like, I don't know, red team, blue team, And the red team can inject bug, the blue team can show that it was able to catch them, so that you can gain that confidence. So I think combination of these techniques, like traditional metrics and also new approaches that can make sure that human can rely, will definitely increase confidence over time. And I'm sure that, like, I don't know, within 1 year or 2 years, the confidence level will definitely increase when human can see LLMs are improving. And also, it's not just um, flow engineering and prompt engineering. LLMs itself is improving significantly. Every generation of the new models are adding new features and getting more reliable. So it will happen over time.
As we've seen the floor of capability rising, lots of engineers are saying they can sort of make these agents themselves, right? What would you
Yeah.
say to those guys?
Yeah, it's also another good question. So, completely agree, the capabilities are definitely increasing and people can do more stuff with available AI assistants and so on. But there are several things that we have done so that we can get better results for chip design. One thing is what we call mental model. This is the source of truth for all the agents that we have developed. And what we do is that instead of just relying on LLM to understand the design, we combine static parsing, elaboration, and we use like tools like Verific, Jasper, Excellium to fully understand the design hierarchies like interfaces, connectivities, ports, parameters, and so on before we go to LLM and ask like reasoning questions. So if you combine this static parsing and static analysis with LLM, you can get much better and more reliable results. So we spend a lot of time generating this mental model in the beginning, and then all of the agents are using this as a source. So that's like we spend a lot of time on that, and we know that our results are significantly changing based on this mental model. Just to give you an example, the test correctness, if you just do based on RAG and using like available capabilities, we get about 42 to 45% accuracy on test. And as soon as we added mental model, our results like were 85%. So it's a pretty significant jump. So that's one key advantage that we have. The other thing is that um, so we have a lot of nice EDA tools at Cadence, like for example, Jasper, Excellium. We have a autofocus that can statically analyze your design and help you with debug. We have Code Miner, we have Wave Miner. So a lot of nice features that we can use to give feedback to LLM and divide the problem into multiple steps, and make sure that at the end we get better results. So again, with all of these key technology updates, we have seen that we still, with the cheapest stack, we can get much better results compared to other like general assistants. So that's our key advantage. And the other thing is that like making enterprise level product in EDA is not easy. Um, and like even for other EDA tools, people have tried multiple times to make their own tool, but I think EDA is very, very challenging, and making it enterprise level is not easy.
So, just so I understand correctly, this mental model that's being created, what's the data feeding it exactly? Is that coming from companies? Where's that coming from exactly?
So this is like we have an agent for that, and that agent can read all your specs, your RTL. If you have, I don't know, high-level models of your RTL, block diagrams, bug reports, anything related to your project, we will read them and try to fully understand your design. And as I said, we also will parse your RTL, and we use all of these together to generate a structured representation of the design, which we call it mental model.
Do you see verification headcount being squeezed by AI?
I don't think so, actually. And I have seen organizations that are like representing this as like cutting headcount and budget and so on, they always fail and they face a lot of resistance. I would say this will just enable verification engineers to go faster and do more stuff. And like, as you know, for AI to improve, we need more chips and maybe chips with stronger and better performance. And right now, AI improvement actually is blocked by the chip design process. So this process will just enable chip designers to go much faster and deliver better chips. But doesn't mean that we need like less verification engineers. In fact, this will enable designers to go fast, and because of that, we need more verification engineers to use this tool and verify more designs. So I would say we'll just enable chip designers to do more stuff and go faster. That's it.
Do you see agents being more effective? This might seem like a bit of a strange question, but more effective in design or verification? Where are you going to get the biggest improvements, do you think?
Definitely verification for sure, because verification, if you think about it, all the problems in verification functions are reasoning problems. And we know that these agents are perfect in reasoning. Design is also like benefiting a lot from AI because it's also understanding the spec and doing coding part, which is again the key strengths of AI. So I would say verification for sure, and we have seen very good results. Design still, I think there's more time so that we can see better results, because when you are designing, you need to also think about optimization, like PPA optimization, like power, performance, area optimization. So those stuff should be also considered. So it's more challenging, but as I said, if we can provide more feedback to LLM so that when they are generating the result, they can get some estimate about power and performance, I'm sure they can also do a good job over there. But it takes more time for that to happen.
What skills do you think verification engineers are going to need in the next 5 years they haven't in the last 40?
Yeah. So I would say for future, my experience is that if you have better spec that has more details in some structured representation, LLMs can do much better job. So I think their skills will be towards like writing better specs for AI so that they can read that and do better job. I also feel that prompt engineering is another good skill for verification engineers. Like we have seen less experienced verification engineers when they use our tool. So we have a telemetry system and we can track how many tokens they are using. And we have seen that more experienced engineers, when they do better prompting, they can use less tokens and do more jobs. But junior verification engineers, they need to spend a lot of time like iterating until they get the results. And because of that, the cost for LLM is high and the number of tokens they are using is high. So I think that skill is critical. Also, sign off is another, I think, key skill that verification engineers will need. And sign off is something that like AI cannot do that. AI can generate test plan, it can generate code, it can like help you debug, but the final sign off should be done by human, and that cannot be replaced.
So you mentioned junior engineers there. Where do you see junior engineers in this whole flow? Because obviously a lot of the work they'd typically be doing is being automated, right?
Mhm. Yeah. So I would say, so I have seen different cases when customers are using our tool. Like we have seen companies that they wanted to do formal verification. They know that formal verification is very important, but they didn't have enough talents because there is always lack of talents for formal verification. So I've seen that with our tool, with ChipStack, they can even run formal verification without knowing how formal works. So that will enable like even junior verification engineers to do more stuff, even if they don't know UVM and Jasper and formal verification. So that's one key advantage over there. But I see the main benefit is coming for experienced chip designers, because at the end of the day, so far, the way we are framing our tool, we are saying this is a junior verification engineers, and they have to be experienced engineers to mentor this tool and review the results and give feedback. Otherwise, it won't get the best results. So again, to just summarize the answer to your question, I see this tool is useful for both junior engineers and and experienced verification engineers. But the most value is coming from more experienced people.
Hamid, fantastic. I thought this was a very useful conversation. I know a lot of people
Sure.
who will find a lot of value out of it. I really appreciate you coming on. Thank you very much, mate.
Of course. Thank you for having me. Thanks you very much.